In this video, I am going to talk about LDR sensors. LDR stands for light-dependent resistors. As the name suggests, it's a resistor whose resistance depends on light. This is the most common circuitry symbol for an LDR. It is not very fancy, but what it effectively means is that we have variable resistance which goes down as light intensity increases and gives rise to more current. When the light intensity is low, or when the environment is dark, the resistance increases, inhibiting the flow of electrons. This leads to a light-dependent resistance that can be used for sensing applications. This is how a typical LDR would look. The design consists of two metal contacts and a heavily doped N-type semiconductor placed on a lightly doped N-type semiconductor, which is placed on a semiconducting substrate that can be either made up of P-type or N-type. When we look at the microscopic level, the idea is very simple. Light consists of photons that are absorbed by the LDR, and the absorbed energy can create an electron-hole pair in the semiconductor. Like all semiconductors, LDRs have a valence band filled with electrons and a conduction band. The frequency of the incoming light should be high enough so that the energy absorbed is enough for the electrons to be promoted to the conduction band. As the intensity increases, more and more electron-hole pairs are created, which give rise to more current and lesser resistance. This can be best understood by plotting a plot of resistance versus the intensity of the light. When the environment is dark, there are not enough photons to create electron-hole pairs, and therefore there is no conduction of electrons, and the LDR behaves like an insulator. As the intensity increases gradually, the resistance of the device decreases exponentially. An extremely important application for LDRs would be a simple implementation in our streetlights in order to automate them. When the day is bright and there is enough sunlight, streetlights could be kept off, and as the day progresses, it gets darker, and the variation of the resistance in the LDR could be used to send in a signal to switch on the lights. This would be very useful in conserving energy in streetlights and other illumination applications. Thank you for watching.